All right. X6E, pretty much examinable exam 1 skill. They want to know that you can solve x-axis intercepts. Now with my previous videos, you should be able to get a general sense of a shape of a graph. You should know your exact values and somewhat symmetry properties. Now we tie it all together and we need to find x-axis intercept to finish that puzzle of the graph. Now here's an example just so you get to visualize what's actually happening, and there's multiple techniques to solving this. Your teachers or your tutors in the past may have taught you differently. I don't care which way you do it. I'm just going to show you the one way that I normally teach it because it's less thinking, but it's not as efficient as other ways. Yeah? Here we go. Consider the graph of y equals sine of x. This is what we know it looks like, sinusoidal, starting from the center at 0, 0. So midline to max, mid, then minimum, then mid. That's your typical sine graph look. If we look at the sine equals half, when we say solve for when sine of x equals half, what we're asking in this sine graph is that when we know there's a maximum of 1 here, then when does it equal to half, which is this line here? That's when sine of x, the graph, will actually equal to half. That's what it means. We can clearly see there are 2 key points, one here and then one here. So you generally expect 2 solutions within one period or one cycle. So when you rotate around the unit circle 2 pi distance, which is this highlighted graph that I've drawn, you expect 2 solutions or 2 possible answers where sine can be half. So if you look at the unit circle, what does it mean? Sine represents y values. If a unit circle has a radius of 1, the maximum y value is 1. What I'm asking is, when will the y values round this Cartesian plane, where on that circle will I have a y value of half? Well, the logic is that only these 2 points, that point here in quadrant 1 and quadrant 2, that's the only point where half for the y coordinate would exist. That's why we say sine is positive, which is positive half, positive in quadrant 1 and quadrant 2. What we don't know yet is what x is. Okay, and x is obviously the cosine. Now if I draw that, we can see, here we go, this is the line to the center, this is the line to the center. And if I do a dotted line, we can see this is a right angled triangle on the left, and this is also a right angled triangle on the right. They're symmetrical. Whatever this angle is here, okay, so whatever that angle is here, that must be equivalent to this angle over here because they're symmetrical. They both have a height of half. The only time now, the only part that you got to calculate is back to your exact value, sine of what angle, so what distance, remember radians is the distance, angle is the rotation. What's the distance in terms of radians? Sine of what will equal to half? Smart. Pi on 6, which is 30 degrees. Very good. So pi on 6 distance or 30 degrees rotation will make a height of half. But that means 30 degrees on this direction, rotating from the 180 point, if I rotate it back 130 degrees, I should also get a height of half because it's the same triangle. That means this is also a distance of pi on 6. And so the 2 possible answers are, you can see I'm starting from this point right here, that's 0 degrees or 0 radians. I had to move 30 degrees up, so 0 plus 30, or 0 plus pi on 6 in terms of radians. That will tell me when I get to my first solution. So in your bottom here, I would say that the first solution is 0 plus pi on 6, which is the distance, or you can do 0 plus 30 degrees, but remember, you've got to work in radians now. So the first solution should be at pi on 6. The second solution is I actually am short of this point, which is at pi. I had to rotate all the way and I stopped right there. I'm pi on 6 away from pi. So the logic is then pi, take away pi on 6, will give me the leftover. So that's why we say, yep, here's your pi is where we want to get to, but we're short of it by pi and 6 because we know the distance is pi and 6 distance there. So pi minus pi and 6, again, that's 5 pi and 6, making sure that you know how to use your fractions. And that is symmetry properties applying to solve for your x-intercepts. Now, what's the challenge? Well, we're saying on the graph here, pi and 6 is here. Then your second solution must be then very close to pi, but it's 5 pi and 6. The problem is that there are infinitely many possible solutions. Can you see that? We assumed that it was from 0 to 2 pi because we're doing a unit circle, and we're assuming these are the two solutions part of the domain. But then there are so many others. There's still these points over here. I haven't told you where the domain was. It could have been from negative pi to 0. Then these two wouldn't be part of the solution. So now, what's the point of getting the pi and 6 and 5 pi and 6? Students need to realize that to go from this point, so pi and 6, to get to the next point, isn't that just one full cycle again? See that? See, if I went one full cycle, one all the way down and went back up, that's a nice period of 2 pi again because I'm landing exactly at the same spot again. So if I want to know what the next x-intercept is, all I need to do is add on a period to pi and 6. Add on the period to pi and 6, that'll give me the next one. So pi and 6 plus 2 pi, okay, that would give you, what, 13 plus 2 pi. So that's 13 pi on 6 there. This one here must be 13 pi on 6. If I want to find the next one, notice that it is just 5 pi on 6 moving a full revolution to get there. That's one period. So again, what you do to get there, same thing. You add 2 pi plus the 5 pi on 6, which 6 times 2 is 12. 12 plus 5 is 17. So I know the next one is 17 pi and 6. Usually after this, I can already see there's a pattern. Have you noticed the pattern? Pi and 6 to 5 pi and 6, that's a distance of 4. 13 to 17 is also a distance of 4. And then the distance from 1 pi on 6 to 13 pi and 6 is 12 pi. So all you have to do now is just keep adding 12 to the 13 all the way to the right. And that will get you all the possible answers. I started with pi and 6, add 12 to it, it's 13 pi and 6. Add 12 to it, that will give me, 25. Add 12 to that, it's now 37. And then I know the second coordinate, the one right next to it, is only 4 units away from this one. So this one would be then 5 pi and 6. 13 plus 4 is 17 pi and 6. The next one is 29 pi and 6. And the next one is 41 pi and 6. And I can keep going until where the domain is. And that's how I normally teach my students. Find the first two. And the next ones is just, oh, sorry, that's not the first two. These are the first two. Find the first two from your 0 to 2 pi. Doesn't matter if it's even in your domain or not. Find that first and then add or subtract by 12, by the period, and you can find the rest up until the domain you need. It's not as efficient, but you pick up a pattern and it's the most simplest brain dead way of finding all the solutions. There are many other ways. There's proper ways to do it where, it's closer to 4 pi, so 4 pi plus or minus the pi and 6. I think for some students that's great. Some other students may find that trickier to understand. I personally like to visualize it through the graph. So you only need the first 2 points, and it doesn't matter where on the sine graph or the cosine graph. You add on the period, and it's about listing it all out and then ticking, crossing which ones fit the domain and which one don't. That's my tip. Okay, and that still applies even for the more complicated ones. So this one I gave you as sine of x equals half. If you have a look at the very last problem I gave you, and this one, I gave you a dilation. In fact, I could make this more complicated by adding a translation vertically as well. So let's see if, no, I haven't got one there. But if I wanted to make this harder, I could have done something like, 2 sine 2x plus pi on 3 and then minus 1 equals 0, hypothetically. And that's all the transformations you can get. And their application is still the same. There's no difference to what I would do for this question versus sine of x equals half. I would do exactly the same thing. Whatever method I'm going to use for sine of x equals half is exactly the same for this one. The only difference is you've got to be careful with the period. This is what the examiners will change. I promise you in the exam, they will never give you an x. There will always be a dilation factor. It's either 2 or 3. They never do more than that just because it's just too many solutions. Yeah? So they stick to 2 or 3 and they'll just play around with that transformation. Okay? So let's start off with a simple problem first. Let's do this one where I don't have a dilation just to get you to practice solving the x-intercept. And then the next one, I'll do it where I'll show you exactly the same technique. The only small difference is what I do to the period. Okay? Here we go. Let's practice this one. Example 1. Find all the solutions for 2 cos of x equals root 3. So here we go. Let's do it again. Same thing. We know the domain is 0 to 4 pi. Remember, I don't care about that for now. I just find the first 2 solutions. Okay, so here we go. Our goal is to find x. So remove everything. Divide 2 on both sides. Cos of x is equal to now root 3 on 2. Next step. I want you to visualize that. Cos represents the x coordinates. You're asking, in a unit circle of the maximum length for the x coordinates are 1, root 3 on 2 is probably somewhere over here. You're asking, where on the unit circle will I have an x coordinate of root 3 on 2? That's what you're asking. Let's draw in the points. Here we go. You can have that point there and this point here, quadrant 1, quadrant 4. These are the only 2 points where you will get a length, which is cos, the adjacent side being root 3 on 2. Going back to your exact values, let's test again. Cos of what angle or what distance will give you root 3 on 2? Let's go with someone different this time. Krish, exact values. Cos of what angle will give you root 3 on 2? It is pi and 6. Again, for those who've forgotten the hand method, you want cos to have 3 fingers. The only way cos is going to have 3 fingers is you have to put this finger down. And that was 0, pi and 6, pi and 4, pi and 3, then pi and 2. So yes, the angle must be pi and 6 in order to have 3 fingers on your right-hand side. So hence, we now know when you're trying to find what cos inverse means is saying what angle will give you root 3 on 2, and you figured it out. The first one is that for the triangle to have a distance of pi and 6, that will give you root 3 on 2 as your x values. Okay, so that's what you're saying there. Very good. So we got our first answer. It was 0 plus pi and 6. Great. You got pi and 6 as the first solution. Second one. Remember, there's 2 points here. One's going up, pi and 6. The other one, you can either read it as now, short of 2 pi by pi and 6. So this is where 2 pi is. 2 pi is over there. You're either short of 2 pi by pi and 6, or you can say 0 minus pi and 6, which is negative pi and 6. Up to you. Doesn't actually matter which one you choose. You just need 2 positional answers. Okay, so I personally like to work in positive numbers. So I would have stuck to 2 pi minus pi and 6, which is, what's that? 11 pi and 6. Okay, so I would have stuck with those 2. It actually really doesn't matter which one's your answer. You could have done negative pi and 6 and then followed on with a period, and then you'll find all your answers. Okay, you just need 2 points. So I like to stick with pi and 6 and 11 pi and 6 because they're positive. And the nice thing is, you're done there. So there's nothing more that you need to do to the x's. You've got x. Unlike the next problem, they'll have all these other things here like 2x minus pi and 3. That's when you start moving things across. But right now there's nothing. So you stop here and you say, okay, now the domain is 0 to 4 pi. The period It's 2 pi on n. N is currently 1. So really, your period is still 2 pi. Hasn't changed. So that means if you want to find your next two solutions, you literally add or subtract both of these solutions by your period, which is 2 pi. Add or subtract by 2 pi. Okay, can you see that? So once you get your first two, to get to the next one, you're just adding on the period. The period is 2 pi, so I'd need to take pi and 6 plus 2 pi, and hopefully you picked up a pattern here. 2 pi, if you convert that out of sixes, that's the same thing as writing 12 pi on 6. So you're really just adding on 12. Yes, Emma? All good? Yep. So all I'm doing now is I'm going to add on 12. So pi and 6, which is 1, plus 12 is 13 pi and 6. Add another 12 is 25 pi and 6. And then another 12 is 37 pi on 6, which is very similar to the problem we did beforehand. And then you can do the same thing for this one. 11 pi and 6. You're going to add now another 12. What does that give you? 11 plus 12 is 23. 23 pi and 6. So we can see the distance between them. Is that right? That's plus 10. Yes, plus 10. So the distance between them is 10. Each one's 10. So the next one must be 35 pi and 6. The next one must be 47 pi on 6. Okay, can you see how I'm just looking at the patterns? I'm looking at the patterns for each one. How far is each one between each other? This was only 10 units away, 13 to 23. Then the next one must be 25 to 35. Next one must be 37 to 47. And you can keep going until you get a 4 pi. Now 4 pi, if you convert it out of sixes, that's the same thing as writing 24 pi out of 6. So have I gone too far? Absolutely. 25 pi is here already, and we said that 4 pi is up to 24. So this doesn't get included, this doesn't get included, this doesn't get included, this doesn't get included. But can you see how easy it was for me to find all the solutions to the right? And I can do the same going back to the left by simply moving back and forth by the period. Okay, so for some students, they may find that a bit tedious by just adding, subtracting, and feels like trial and error. If you want to be more specific, then you actually need to work with the revolution. So you got to figure out how many rotations you actually have to do. So some teachers might teach it that way. I teach you this way. It's just the most brain dead way of doing it. You just literally keep adding the numbers of the patterns that you see up until where you need. So right now I know the ones that we can keep. Pi and 6, 11 pi and 6, 13 pi and 6, and 23 pi and 6 at least is to the right. Now I got to go back to the left and check, what if I minus by 2 pi? So what if I minus 12? But if you minus 12, this one will become negative pi and 6. This one will become, what's that? 1 minus 12 is negative 11 pi and 6. And since it said 0 to 4 pi, those two solutions are also out. So what's my final answer for this question? It must then be pi and 6 the smallest, 11 pi and 6 the next one, 13 pi and 6 I can keep, 23 pi and 6 is my final one because the domain stops at 24 pi and 6. Okay? So that bit there, this final bit, is how I do it. There's a lot of different ways. I pretty much know there's at least 3 ways already to get to that final answer. You choose whichever way you like. So whether you learned it from a friend, from a tutor, from your previous teacher, I don't care. You just need to get the right answers. Okay? All right. Let's do one now where they add in a dilation. So flip over the page, and that's the last example I'll do. The other questions, I'll fill in the solution. It just requires a bit of problem solving with symmetry properties. Okay? Here we go. So this is the skill you want to take. By the end of your term 1 holidays, I expect these skills to all be sorted. So you can solve and you can sketch. Yeah? Here we go. Let's solve this one. Note the period has changed because n is now 2. So the period must be what? Pi. Very good. So 2 pi divided by 2 gives you pi. So now we know the period is pi. Now we got to solve. So right here, when you get up to this step, don't get intimidated. Do exactly what you've been doing. Get rid of everything until you get to x. So now I need to get rid of sine. Opposite of sine is sine inverse. So sine inverse to the right, sine inverse to the left. And you get this line, 2x plus pi on 3 is equal to the sine inverse of half. And this just basically means, going back to your exact values, sine of what angle will get you half? So I want a half. I want these 2 points here. I need it to equal to half. Sine of what angle will give you half? Pi and 6 again. Okay, so I should have changed the angle so that we all practice our exact values, but clearly pi and 6 was a nice one to use. So I can see it's 0 plus pi and 6, and the other one's short of pi by pi and 6. So my two possible answers at the moment, first one's pi and 6, because there was 0 plus pi and 6, and the other one is short of pi and 6, short of pi by pi and 6, so it should be pi minus pi and 6. So your two possible answers so far is pi and 6 and 5 pi and 6. Don't forget the left-hand side. The left-hand side is still 2x plus pi on 3. And this is what I teach my students to do. So from this step, literally, solve the way you normally would. Get rid of the pi on 3 on the left. So subtract pi on 3 on both sides. So this is what you have to do. Minus pi on 3 on the left. Minus both of these solutions by pi and 3. This cancels out. 2x is equal to, and depending on your fractions at this point, you need to know how to do 1/6 take away 1/3. 1/3 is the same thing as 2/6, so really you're taking away 2. So if you take away 2, 1 take away 2 is negative pi on 6, and 5 take away 2 is 3 pi on 6. You just got to be really fast with your fractions. Okay, so at this point, if you're struggling with it, practice some fractions, learn how to work with fractions there. Okay, so 3 pi and 6. All right, next one. Now that you've done that, the last bit is you want x, so get rid of 2, divide both sides by 2. Divide this by 2, divide this by 2. 2 divided by 2 cancels out, and you're finally at to the last step. X is equal to negative pi and 6 divided by 2. For those who aren't good with their fractions, when you divide by 2, it's the same thing as saying timesing half. So you're timesing 6 to the 2. So you should get negative pi on 12, and then 3 pi on 12. I know I can simplify that. I'm just leaving it there because I like them all to be in 12s, and I just add on the period or subtract the period. Okay? So here we go. There's our two solutions. Doesn't matter what the numbers are, you just need 2. Yeah, just need 2 for sine and cosine. And then from here, add and subtract the period. Now you told me the period before was pi. Denominator's out of 12. So that's the same thing as writing 12 pi out of 12. So all you have to do now is add and subtract 12s until you reach the domain. Now what's the domain? 0 to 2 pi. So our goal is to go from 0 to 2 pi. Now negative pi on 12 is a problem. That doesn't get counted. But regardless, I'm going to keep adding, add 12 pi on 12 up until I get to 2 pi. So here we go. If you keep adding on, now just to keep it all organized, I'm going to do it like this. I'm going to add it vertically down for this one. So if I add 12 to this one, you get 11 pi on 12. If I add another 12 to that one, I get now 23 pi on 12. If I add another 12 to that one, I get now 35 pi on 12. Then you do the same thing for this one. Add 12 pi for that one. 3 plus 12 is 15. 15 plus 12, well, if you look at the distance, 11 to 15 is 4. So you can add 4 to the 23. So 27 pi. And add 4 to the 35. And I can keep going. But remember, we're stopping when you get to 2 pi. And 2 pi, 0 to 2 pi as your domain. 2 pi is 24 out of 12. So I should have stopped right here. These are the ones I'm keeping. Sorry, except for this one. In terms of adding. We haven't tried going backwards yet. If you go backwards, we've got to subtract. So if you go backwards, minus 12, this will now be negative 13 pi on 12. And then this one, 3 take away 12, would still be a negative number anyway. So That's what, negative 9 pi on 12. You can't include them. So my answers are 3 pi on 12, 11 pi on 12, 15 pi on 12, and 23 pi on 12. Those are my final answers. Obviously, simplify where you can afterwards. Now you can see how I kept it. Everything was exactly the same technique as I did before. Get the first two solutions, which is here. Doesn't matter what the number is, but they need to represent each quadrant. One represents quadrant 1, and the other one represents quadrant 2. Okay, and because of that, I just simply add, subtract the period until I get all my possible solutions in the domain. That to me is the easiest way to explain the logic. The better you can visualize the graph and the better you can visualize the unit circle, then you don't have to do it this way. There's many other ways to do it. Yeah? All right, team, I'm going to stop there. That is the skill from last year that was important to learn. This year's your second time to learn and master that skill. I can put in some videos from last year that I made for my students if you want more practice solving for those kinds. But exam 1's questions, there's plenty of those circular functions ones. So if you want, I can go onto a website that we have. It's called Smarter Maths, and I can print out all the solution ones for solving for x-intercepts if you're struggling with those ones. Okay, and then I can just print it out a bunch that you can practice. Cool? But that's it for today's lesson. For the next few examples, it's literally just now symmetry properties and thinking about your unit circles. So I'll write up the solutions, but have a go with those ones if you want. Okay? Remember, homework over the holidays, I'll post up on Teams. If you want a hard copy, come to me probably tomorrow. Actually, tomorrow's June led, so Thursday, drop by my office. I'll have hard copies ready if you want them. Otherwise, digital should be good.